Okay, YouTube, in this video we're going to focus on what we call the division algorithm. And essentially what this is a nifty tool that says if we take some function f of x and we were to divide it by some divisor function d of x, what's going to happen is we get this right here. We would say that we would get some quotient of x, quotient polynomial of x, plus some remainder polynomial of x. And essentially what I want you to see is this is the remainder polynomial of x over d of x here. If we were to take both sides of this equation times d of x, the divisor, times the divisor, what we would end up with is some statement that says, well, f of x, the original polynomial, really that's the same thing as what you got when you divided it by the divisor times the divisor again, and then these would cancel out and we say, well then plus the remainder expression right here. So essentially, excuse me, if we were to say something like 120 divided by 6 here, we would say that what I would get up top is, of course, 20 here, and we'd say that this would all cancel out. But basically, what you're seeing is that the original thing here, 120, can be rewritten as the quotient, which is 20, which is our quotient right here, times the dividend, or the divisor, excuse me, plus the remainder of 0 here. And so what this allows us to do is really write something in a factored form, okay? So we say if f of x and d of x are polynomials, and d of x is not equal to 0, and the degree of d of x is less than or equal to the degree of the thing that we're dividing by d of x, then there exists unique polynomials q of x, which is our quotient, and r of x, which is our remainder, such that the original function can be rewritten as what I divided by times what I got left over plus the remainder part of this. And so we say the remainder, r of x, equals 0, or if it is of degree less than the degree of d of x, okay? And if the remainder is equal to 0, then we say that d of x, the divisor, actually went into f of x evenly. And so what that would mean is that d of x is a factor of that thing, but also that the quotient, what we get left over, is also a factor. So let's go ahead and do this. We're going to divide 7 minus 11x minus 3x squared plus 2x cubed by x minus 3. And we're going to express our result as a quotient plus a remainder divided by the divisor. So let's go ahead and take a look at our first problem here. We need to rewrite this so that it's in standard form. So we say 2x cubed minus 3x squared minus 11x plus 7. And we're dividing this by x minus 3. So let's go ahead and get started here. We say x times 2x squared would give us 2x cubed. So I get 2x cubed when I multiply this by x, and then 2x squared times a negative 3 is negative 6x squared. So we're going to subtract off all of this. So we're going to add the opposite here. So these cancel out, and it looks like we get left with 3x squared, and we'll carry down the 11x and start up again. So now, what can I take times x to get 3x squared? Well, we could take it times a 3x. So 3x times x is 3x squared. 3x times a negative 3 is negative 9x. And again, we're going to subtract all of this. So we'll add the opposite of these terms. So these cancel, and we get left with negative 2x. And then we'll carry down this 7. So what we end up with here is a situation where we say, well, what can I take times x to get negative 2x is negative 2. So this negative 2 times this x here is negative 2x, but negative 2 times a negative 3 here is a positive 6. And when we subtract these this time, this whole quantity here, what we're not going to see happen is we're not going to get 0 for a remainder. So we got a remainder in this case. So what this said was express the result in the form of a quotient plus a remainder divided by the divisor. So here's our quotient here, but we're going to say plus now 1 over the thing we were dividing by. So our quotient is 2x squared plus 3x minus 2 plus 1 over the thing I was dividing by here. This would be all of this that you see right there. So now let's take a look at this last one here. We want to divide this by this here. And this one's a little bit different. I did want to take a look at an example where we're missing some terms. So when I fill this in here, our dividend, 2x to the fourth plus 3x cubed, I notice I have no x's to the second power. So you actually need to fill in 0 x's to the second minus 7 x's to the first minus 10. So we get this here, and then on the outside, the weird thing is you don't actually have to fill in any missing zeros here if you have any. So now, dividing this out, let's start with what we have in front. X squared times what would be 2x to the fourth. And I would say 2x squared. If we multiply by that, we'd have 2x to the fourth. So we have 2x to the fourth. Now 2x squared times a negative 2x is a negative 4x to the third power. So subtracting all of this now, so we'll add the opposite. We're going to get these to cancel, and it looks like we have 7x's cubed. So we're going to carry down this 0x squared. That's important here. And start again. We say x squared into 7x cubed would be a 7 and an x. So 7x times x squared is 7x cubed. And then 7x times a negative 2x is a negative 14x squared. So here's what's going to happen here. We're going to subtract off all of this. Adding the opposite, we find out that the 7x's cubed cancel, but we get left with actually 14x's being squared. So now we'll carry down our 7x and start again. X squared times what would be 14x squared? And I would say, well, then 14. So 14 times x squared is indeed 14x squared, but 14 times this negative 2x would be a negative 28x's. And because we're subtracting all of this and rewriting it as adding the opposite, we actually end up with a lot of x's here. It looks like we get 21x's plus a negative 10 or minus 10. So I'm going to put a box around this because now if I say how many times does x squared go into 21x to the first, I notice that this is a higher degree than x to the first is. So this won't go into this. So this is actually what we get as a remainder. And what we're going to do is we're going to write this as our quotient plus now our remainder, and our remainder is 21x minus 10 all over the thing we were dividing by, which is x squared minus 2x. So this is our quotient plus remainder. Cheers.